In the last video, we looked at expanding logarithms, taking a single logarithm and writing it as multiples. Well, in this video, we're going to go exact opposite way. We're going to take multiple logarithms and try to condense them into a single. To do that, I'm going to use the same exact rules, but I'm going to be looking at them kind of backwards. So here they are stated for you backwards. Okay, when we looked at them, we said when you multiply, you add the logs. When you divide, subtract the logs. When you raise to a power, multiply by the power. Well, now I'm going to be going the other way. If they have a multiplication, I will write it as a power. If they have a subtraction, I'll write it as a division. And if they have an addition, I'll write it as a multiplication. So let's write a few as a single logarithm. So for this first one, log base 10, the common log of 25 plus log of 4. So since that's a plus, I'm going to write it as a multiplication, a single log where I'm going to multiply 25 times 4. Now I don't get to leave it like that because I can multiply 25 times 4. That gives me 100. But I don't even get to leave my answer like this because this is log base 10 and 100 is a base 10 number. So my common log base 10 of 10 squared. Log base 10 of exponential base 10 ends up leaving me with my exponent 2. Okay, same story, second verse. I have a minus sign. Well, it's when you divide that we turned it into subtraction. So I want to take this one backward and turn it into a division. A single log with a division of whatever they were logs of. So of 7x plus 6, that will be my dividend. And log of x, that will be my divisor. I cannot simplify 7x set plus 6 over x. So that is my final answer. Okay, so it's not so bad. This one, however, looks a little more complicated. There are products here. Well, it was when you raised to a power that we multiplied. So I'm going to take those powers back. I'm going to call this natural log of x squared plus natural log of x plus 5 to the 1/3 power. I still don't have it down to just one natural log, so I still have another step to go. To write it as a single natural log, I have to realize that it was multiplied to become addition. So I want to take the addition back to multiplication. So that's going to be x squared times, I am going to turn the 1/3 power into the cube root, if I can, maybe, of x plus 5. And that's as far as I can go. So it's really not that challenging, but it is going to take a good bit of practice to get to where it's almost second nature.